we first talked about here. So if you're seeing my screen, you see the question here: find the relative max and min values. And based on the way the answer choice is, it looks like it either has a relative max or relative min, or neither. But you have to first take your derivative with respect to x. So that's 3x squared plus 0 minus 18y. And then you have to also find fy, which is really similar. It's 3y squared minus 18x. Okay, and then here's where it gets a little bit more challenging. You have to we will actually need fxx at some point.
Okay.
And potentially fxy. I'm sorry, and fyy. So we might as well get them now. 6x for this one, because that goes to 0. Fyy is 6y, and then we also do need fxy, which we can get from this one. So it's taking the derivative of this with respect to y. So that's 0, and that's just minus 18. So we need all of those to start, and then we can actually kind of work with this. So you're looking for what are called critical points, and you find by x equal to 0 and fy equal to 0.
Okay.
So we're setting this first one equal to 0, 3x squared minus 18y equal to 0, and then 3y squared minus x equal to 0. And you have to solve this system here. So like if we do a little bit of manipulation here, we get 3x squared equals 18y. If we divide both sides by 18, we get 1/6 x squared equals y. And then you can take this and put it in there for that y.
Okay.
And if you're following, like we're essentially gonna solve it for an ordered pair. And
Okay.
so like it's a lot of work here, but it's super doable. So it's 1/6 x squared times 3. That's me substituting in here. Minus 18x equals 0. So this is 1/36, but then you multiply it by 3, so it's 1/12 x to the 4th minus 18x equals 0. And you can factor out a 1/12 x from both, and you get x cubed minus so 18 times 12 is 18 times 12. I think it's 144. 216 equals 0. And so this, if you set both of these equal to 0, you get x could be 0 or x could be 6.
Okay.
So I don't know if you followed all that, or it's somewhat important, but maybe not right at the moment. But essentially, you get an x and y x value. You have to go back and find the y value from one equation or the other. So like this is a pretty good one. So we said x is 0, and we have from this line right here that y equals 1/6 x squared. So of course y is then 0. That's our first ordered pair. That's our first critical point. And then the other one was x equals 6, and then y equals 1/6 6 squared.
Hold on, give me 1 second.
Sure, of course.
Sorry, my roommate just knocked on my door.
No problem. So you square 6, you take a 6th that, so y equals 6. So 2 critical points.
Okay.
So in some future version of the problem, assume that you could find the 2 critical points. There's one at 0 and one at 6, 6. Okay. So now the part that students don't like, I don't like it either, but this is what you have to know to be able to do the rest of this problem. So essentially, you have to be able to evaluate. You need to get this value d. And this value d comes from the fxx, fyy, and fxy. So that's why we needed them from the previous part of the problem.
Okay.
Okay, so I'm going to show you how this works, but like, let me just go back and grab the value. So fxx is 6x. Fyy is 6y. And then fxy is, where is it? Minus 18. Okay. So you find D for each point. Okay. So first thing is you have to evaluate the second derivative, fxx, at 0, 0. So first do it for this point 0, 0. So that's this first part is 6 times 0,
Which is 0.
which is 0, which means it doesn't really matter what that is, but we'll just keep going here. This is 6 times 0 for the next part, minus 18 squared. So it's 0 times 0. And you only care about the sign. So you'll see that this is whatever this number is, it's negative. So D is less than 0. So if D is less than 0, then it's a saddle point, which isn't what we wanted, but that is,
Okay.
that's, so now we do it for 6, 6. Okay, so for 6, 6, it's 6 times 6,
Mm-hmm.
6 times 6 minus 18 squared. Okay, so that's, whatever that is, we'll get those numbers. It's 36 times 36 minus 18 squared. It's 972. So D is greater than 0, which doesn't help because it means that it could be a min or a max. So notice it comes down to the value of fxx. If fxx is greater than 0, then it's a relative min. If xxx is less than 0, then it's a relative max. So fxx is this 6x, but because you're testing it at the critical point, here's 6, 6. It's positive, so it's a relative min.
Okay.
So here's what we can say. Here's how we can answer this question. Let me go back to, let me try to be clear here with this next part. I'm just going to snip in the this. Okay, so your problem is that it has a relative min at 0, 0. I'm sorry, 6, 6. And to get that actual min value, we have to go back to the original function and plug in that ordered pair here. So we have to put 6 in for x and 6 in for y. 6 cubed plus 6 cubed minus 18 times 6 times 6. And this number will go in that box there. So let me get that value for you.
I got negative 216.
I got that as well.
Okay. And the like A2.
The second box, right?
Yeah.
Okay.
And then would you put in 0 for so negative 216 would go into that box that your cursor's over, and then 6 come.
Yes.
Okay.
Because it is a relative min.
And then you just leave the upper part blank.
Yeah, you have to first choose one of these. There is no, I'm sorry, there is no, I forgot that those ways were, yeah, you have to choose. There is no relative max. The other point was at a saddle.
Okay.
Yeah, sorry, I can now understand what you're asking. Now hopefully it's very clear.
Okay. I will send you the next problem.
Okay.
It looks like these ones are just kind of going to be the same thing.
Right. So how many of these do you need to get through tonight?
So in this lesson, there's just 4 more, and then in the next lesson, it's 5. So just a total of 10 questions.
Okay.
All right. I accidentally sent you nothing.
So at some point, if the goal is to get through these, we can do it a faster way.
Okay.
But if the goal is to like see the steps, then it's going to be this length amount of time for each question roughly.
I mean, I'm like understanding it a little bit.
Yeah.
I emailed one of like the tutors at ASU. So she's gonna like sit down with me tomorrow and actually like teach me how to do all these stuff as well. Cause my professor just sent us these things and said do it. So
Yeah. Yeah. So I'll just keep working through them then, because that's truly, I mean, if you really want to understand, that's the best way to do this. So
then I also just like watch the videos back too.
Okay. Yeah. And if you want to change anything, just let me know. But process is basically the same. You got to find fx. Okay.
Mhm.
So that's 2x plus y. And then I like to come over here to the right and find fy. So fy is x plus 2y minus 10. And then my preference is actually to find fxy kind of right away, and then do fxx because it's right here. So it's the
Yeah.
derivative of this with respect to y. So it's just 1. And then fxx is 2. Fyy is also 2. They just happen to be the same. Okay,
Yeah.
so your process now is to set fx equal to 0, fy equal to 0. So these lines up here basically.
Okay.
And think of it as a system. Sometimes the system is nice, sometimes it's not nice, but that is the nature of these problems. So it's 2x plus y equals 0, x plus 2y minus 10 equals 0. So in the case of a linear system, and this will be reviewed, when you have a linear system, your options are substitution, elimination. If you're allowed to use a calculator, you can use matrices. But in the last problem, it was a nonlinear system because it had quadratics. And essentially the only approaches that work are substitution or graphing if you have access to that technology. But generally you just use substitution because it's fastest here for these. So you sub in that right there, x plus 2 times minus 2x minus 10 equals 0. So that's minus 4x, ooh, minus 3x, ooh, it doesn't look great, minus 10 equals 0. So x equals negative 10/3. Wow, that's horrible. And then y is going to equal minus 2 times minus 10/3. So it equals 20/3, like that. So you have your ordered pair, negative 10/3 and 20/3. And you go back to this thing that I grabbed here. This is from a really good resource from University in Texas, Lamar University. But you got to find this d again. So you have to evaluate the second derivative at this point of x, y derivative at second derivative of y at that point, and then the intermediate derivative. So what's interestingly is this one, they're all constants, the ones that we care about, like there's nothing to evaluate. So it ends up being that d equals 2 times 2 minus 1 squared. Just double check that. Yeah. So this d is equal to 3, which is greater than 0. So it's either this one or this one. So you have to then look at fxx. Fxx is the first one. It's greater than 0. So this one is a relative min. So it's 2 steps. You got to find d, that's step 1, and then maybe this other thing. So this right here is a relative min. So in terms of the boxes that you want to check here,
It would be the function. It would be like the same thing as
Yep.
last time.
Yep. And we got to actually go and find the relative min this time, which is, a little hassle, negative 10/3, comma 20/3. And then we got to go back to that original function that was given and substitute those values in. And it is expecting a fraction. So if you need help with your calculator on that, I can provide that. But let me do the calculation here. We can compare, see if we get the same thing.
Okay.
All right, so we got X. All right, so I get negative 1/3 for this.
I'm still working on mine.
Okay.
Again. You said it negative 1/3, right?
Yes.
Okay, me as well.
Great. So that one was nice because even though it was a fractional critical point, the calculation of this D, which I don't remember what it actually is, but it's a, anyway, the point is, and so you need to know this, like this you need to know. And then usually you have to memorize this. Maybe your instructor will give you a cheat sheet on the exam quiz. So
You said you got that from the university. You said a Texas university.
let me send you the link to that in the chat.
Okay, cool. Thank you.
Let me do that right now. Sorry, I usually remember to do that. And you'll see it's straight from Calculus 3, which is where you are in this course.
Yeah.
Okay, there we are, chat.
Okay, thank you so much.
You're welcome. All right, so it looks like another question has come in. Another one of these horrible problems. So we'll, yeah. All right, so again, there's a sequence of step here. Fx, so it's the original function, but then you got to take the derivative up here. So it's always good if you can sort of see ahead that, oh yeah, I'm going to put that out in front. Fy, so you take the derivative of this 7y squared, so that's 14y e x squared plus 7y squared plus 2. Okay, and then, ooh, this is where, oh boy, it gets pretty bad. So fxy, so the derivative of this thing with respect to y now, thankfully y is just in the exponent. So it's 14y times the 2x, maybe show a little more work here. And then you keep the original function. So simplifies to 28xy e to the x squared plus 7y squared plus 2. Okay, and then we got to do fxx. Oof, this is horrible. So that's product rule of this. So it's 2x, and then take the derivative of this with respect to x, which we already did. It's actually this thing here. So it's 2x e to the x squared plus 7y squared plus 2 plus, okay, derivative of this, which is 2, keep the second. Okay, so that's your second derivative. And we do need that because we're actually going to evaluate the critical points there. And the same for fyy. It's pretty similar because it's kind of same setup here. So let me just reduce the size of this and fit it in right here. Fyy is 14y times 14y, because that's the root of this part, e to the x squared plus 7y squared plus 2 plus 14 e x squared plus 7y squared plus 2. Okay, so that all has to be done, but then really what has to be done is you have to set fx and fy equal to 0. Let me copy them so I don't have to keep rewriting. All right, there's those. And sometimes you have to just sort of do a little bit more of an inspection. Like if you set these equal to 0, this is never equal to 0.
Mm-hmm.
And e is never equal to 0. So that's like a good, so you're really setting 2x equal to 0 and 14y equal to 0. And the only place that's 0 is when x equals 0 and when y equals 0.
Yes.
So sometimes even after all that horrible mess, like it actually is not too bad. This is really good because it allows us to actually evaluate this D again. So your D, you have to do the fxx at 0, 0 times fyy at 0, 0 minus fxy at 0, 0. And then you square that one. Okay, so if we go back to fxx up here, 0 out in front, this whole thing goes to 0 because when you put 0 in. But here you get 0 plus 0 plus 2 times 2, so you get 2e squared.
Okay, yeah.
Similarly for fyy, that's 0, 14y is 0, and then this whole thing is 0, but this is 14e squared.
Okay.
Because it's 0 plus 0 plus 2, e squared, 14 up front. So 14 e squared. Okay, and I'm pretty sure like any one of these individual pieces you understand, but there's like a whole lot of stuff to do here. So it's,
Yeah.
So now we need to go find fxy, or we have to use our fxy and evaluate at 0, 0. So that's here. And notice that's 0, so the whole thing is 0. Thank goodness. All right, so your D is 28e to the 4th, which is greater than 0. And if we go to that wonderful chart that I have, it seems to always be the case that it's one of the first two.
Oh, perfect.
So it means, so it's one of the first two because it's greater than 0. And then fxx. So fxx is this first one, it's positive. So it has a relative min there. So again, in terms of your answer, I'm sorry, say that one more time.
I keep going.
Okay. So in terms of your answer, it's the same, I think, as the last couple. There is no relative max. It's because there's only one critical point. When we have more than one critical point, there's the possibility of other things happening here. But in terms of like what you want, there's no max, there is a min. It occurs at 0, 0. And then we got to go put that back into the original function, which is it's e squared. That's what it ends up being.
Yeah, it seems like it's like they're relatively easy, but they're just, like you said, like a lot of steps. And if you don't pay attention, you'll get them mixed up.
I had a physics instructor that I didn't like very much, but he said physics is not a spectator class. You got to get in there and you got to do a lot of problems. And that's kind of what these are. If you don't work these out on your own, you'll just feel overwhelmed by all the steps that are needed to get them done.
Yeah.
See, a new question here is coming through. Right. All right, so again, you got to be able to find fx, you got to find fy, and then I like to find fxy next, fxx, and then fyy. So fx is 2x, that's 0, minus 14. Fy is 2y plus 4. Fxy, you can choose either one of these, but I'm going to go that this first one, you take the derivative with respect to y, which is 0. And then this one is the second derivative of this with respect to x, which is 2. Fyy, the derivatives, and just happen that these are the same again. So again, our next step is to set these equal to 0. So you have 2x minus 14 equals 0. 2y plus 4 equals 0. And we're going to solve those. So it looks like we get x is 7. Just a moment here. X is 7, and then y is -2. But our D, which is all we care about, it's fxx at this point, 7 comma -2 times fyy 7 comma -2 minus fxy at 7 comma -2 squared. Fxx is 2, it's always 2. Fyy is always 2. Fxy is 0. So like we don't have to actually evaluate anything. It's a 2 times 2 minus 0 squared. So it's just equals 4, which again is greater than 0, but fxx is 2, so it's greater than 0. Fxx is greater than 0. So we know that this is another min again. So it's a min at 0, 0. I'm a little shocked that we haven't seen one with a max yet, but that is.
And then it would just be -10, right?
Yeah, let me,
Okay.
I got to go back and look. It's whatever the original function is. Yeah, -10.
Okay.
No, yes, -10. Oh, and it's not, it's at, no. Sorry, no. We have to put 7, -2 back into that.
Oh, okay.
So it will be whatever that ends up being. So x is 7, y is -2. So I get -63 on that.
Yes, I did too.
Okay.
Okay, so this is the last one for the min and max problems.
You can see we're going through them like a little faster each time.
Yeah.
And I think so. This one, it looks like it could have a min, max, or a saddle. Probably has some combination thereof. Okay, so got to find fx, which is 2x. And then here, this could be a little bit complicated, but it's power rule and the y just comes with it. So it's -2xy. Fy is from this first one is 144y. This is 0, and then minus x squared. Fxy, so you take the derivative of this with respect to y, so it's going to be -2x. And notice if you were to take the derivative of this one on the right with respect to x, fyx, it would be -2x, which is the same as that. Fxy equals fyx. Fxx is taking the derivative of fx with respect to x. So it's 2 minus 2y. Fyy, derivative with respect to y only, 144. So you need all those, and then you need the critical points. So you have to set this equal to 0. You have to set this equal to 0. So this one is, how do we want to do this? Let me come over here and solve this one for y, I think. You have to be careful here. Like if you solve this one for y, you get y equals 1, which we might be excluding a point. So I got to be careful here when I'm doing that. So over here, though, we can set 144y equal to x squared and y equals x squared over 144. And so we can substitute that in here. So we get 2x minus 2x times x squared over 144 equals 0. So you get 2x minus x cubed over 72 equals 0. And the mistake here is to, like, you got to be careful not to miss one of these. So I'm actually going to multiply everything by 72. So you get 144x minus x cubed equals 0. factor out an x, so you get 144 minus x squared equals 0. This is difference of squares, 12 minus x, 12 plus x equals 0. So x equals 0, 12, or negative 12. So there's actually 3 places. So for each of these x values, we have to find the y, and we get y from over here. Y is x squared over 144. So what I prefer to do is kind of just do these one at a time. If x equals 0, then y is going to equal 0 because it's 0 squared over 144. If x equals 12, y is 12 squared over 144, which is 1. And if x is negative 12, y is also 1 for a similar reason. So we're not done. This is actually the most complicated problem. From here, I recommend a table.
Okay.
So the tables are going to have x comma y are ordered pairs, fxx, fyy, fxy, and then we get we calculate d all the way at the end. So we're gonna do each of these ordered pairs. So 0, 0, 12, 1, minus 12, 1. Okay, so our fxx, go back here, 2 y. So this was 2 minus 2y. What was fyy? Is it 144? Let's see here. 144, and then minus 2x. So we want to get these values. So this first fxx is 2 minus 2 times 0. 2 minus 2 times 0. So that's 2. fyy, this is always 144. And this is minus 2 times 0. So that's 0. Your d is this number times this number. So 2 times 144 minus 0 squared. So it's 288. We'll figure out what it is at the end. So then the next point, 2 minus 2 times 1. So it's 2 minus 2 times 1. So that's 0. fyy is 144. And then this is negative 2 times 12, so negative 24. Your d is 0 times 144, which is 0, minus this number squared. 24 squared is 576. And then last one here, 2 minus 2 times 1 is 0. And 144. And then this is positive 24. So it's also 576. So they're all positive. Huh. Feel like we had to, but it says use comma to separate answers. So they're all positive. fxx is positive in all cases. So that means they're all relative mins.
Okay.
So let me try to show how that would be answered. Oh, and we got to put the values back in. It's horrible. Okay. Oh, that you just need where the relative minimum is at. So relative minimums are at 0, 0, 12, 1, minus 12, 1. Oh no, I'm sorry. These are negative, aren't they? Because you subtract. I'm sorry. That's wrong. That's wrong. These are negative because you square this last one, but you're subtracting it.
So that would be a maxima?
They're both saddle points because the d is less than 0. And if d is less than 0, then it's a saddle point for sure. So let me snip that in here. If d is less than 0, then it's a saddle point. So you have a saddle point at the other 2 points. Get back to that. So there's no relative max, but there are 2 saddle points. So 12, 1 and minus 12, 1. Why did I not? Oh, okay. Now, having said all that, if it were me and I were a college student again, I probably would go find an online calculator and double check all this, especially if it were for a grade, depending on how important it was. And there's tons of them out there. So if you would like, we can spend a few minutes checking them all, or we can go through some more problems in your next lesson.
I am just submitting my quiz right now.
Okay.
And it looks like we got 100. So that's
Great.
good. And then tomorrow I'll go over it with everyone or like whoever. So I can really like check, because I understand it, but I just know that like I need someone just gonna sit down and like remind me that, remind me like what to do at first.
Sure. This format we're doing doesn't work great for that because I don't have any way to see what you're doing, and I can only show the work and you can follow along, or
Yeah,
but,
and like I'm understanding it a lot, which is good, but yeah.
All right. That's great.
Okay, so I just sent the other question. So now we're
Okay.
doing involving relative extrema.
Yes. Give me a moment here. I get logged out of a couple of things. Google security stuff. So let me get right there. Come on, where is it? There it is. All right, fantastic here. So we got a question in. All right, so these are just story problems. They're the same exact steps, at least for this first one. So one of the nice things about story problems is that if you get only get one critical point, you can just use it. You don't have to actually go through all the steps that we did, but you do have to find the critical point. So x is minus 60x plus 540. Fy is minus 60y plus 600. And instead of finding fx, fxy, because of the story problem, we may have to find them, but we're just going to set it equal to 0. So it ends up being that x equals 9 and y equals 10. Okay, so we can actually just say that is the critical. That's the only place this could happen, because there's only one, and because the problem is asking for it. We're kind of skipping through the the pure math here, but then you actually got to take this and put these values back into the original. So in some ways these are easier, but it's problem specific. So don't take that as general rule quite yet. So let's find P.
Okay, I got 5,630.
Great, confirmed.
Okay. Okay, the other one should have just sent.
Okay, there it is. All right, yes, this one is more complicated, but only because we have to combine some equations. It is the same set of steps here. All right. So they're asking about profit, and profit is revenue minus cost. And they give you revenue, they give you costs. You have to first write your profit equation. So it's this minus this whole thing here. And the more you can do at one time, like if you can, distribute the negative, if you can combine like terms, it saves you some time here. But I'm gonna write it all out since the first time we're seeing this problem. So you're gonna distribute this negative to everything in here. And then you're gonna combine like 4x with the minus 14x and 3y with the now plus 50, what will be the positive 57y. So this ends up being minus x squared plus 4xy minus 9y squared. So again, we're just distributing that in. This is minus 14x, but we got 4x to go with it, so minus 10x. Okay, and then plus 60y plus 3y, so plus 63y, and then minus 7 becomes plus 7. Okay. So then you got to find, and it's just notation, it's px. It's the derivative of this thing with respect to x. So it's minus 2x plus 4y minus 10. And then you got to find py, which you get from here is 4x minus 18y plus 63. Okay, so you set each of these equal to 0. You do not have to find pxx, pxy just yet. We'll see if we need it. And it becomes minus 2x plus 4y equals 10 when I move the 10 over. And then I'm going to do the same thing here because actually it's just a nice system this time, where if I multiply the first equation by 2, put it down here, you're solving a now. Minus 4 add 8y equals 20. Add the equations together. Minus 10y equals negative 43. Ooh, that's not so good. I don't like that. Let me check that I did this correctly because that could certainly play into this. Minus 4xy minus 9y squared minus 14 plus 57 plus, oh, I'm sorry, this is supposed to be a 60. And that's supposed to be a 60, and that's supposed to be a 60. And then we get a number that's a little bit more expected, 40, and then y equals 4. So now you go back and get x. We'll just use this first equation. Minus 2x plus 4 times 4 equals 10. Minus 2x plus 16 equals 10. So minus 2x equals minus 6, x equals 3. And you should be on the lookout for nice numbers when you're doing this, because these are textbook problems. They're supposed to work out nice. So if we go back here, x is type A and y is type B. So I think we said x was 3. I think it's 3,000 because it says x thousand and then 4,000 solar panels. But then we have to add, when we're actually like finding the profit, when we're actually putting it back into this equation, we actually want to use x equals 3 and y equals 4, not the 3,000 and 4,000. Just want to be careful on that front there. So we do need to evaluate this awful function here with x and y. So get those plugged in. Right, so we got
I may have done it wrong. I got negative 88.
that's for the cost, right?
Oh,
Negative
okay.
8, the cost, you got to find revenue. It's this line. It's this line right here. So it ends up it ends up actually being okay. It ends up being I get 112 million for
Okay.
solar panels.
Okay, so after this one, I think I can do like because this will be the third one. I can do 4 and 5 on my own.
All right.
So I just sent you the last one.
All right, we'll see if we can get through it here. There are tons of calculators. Wolfram's one that I like. You know, there's lots of them out there. You got to just know how to use them though. That's sometimes maybe the challenge. So
Yeah.
right, so this one, it gives you an equation. I don't even read this stuff anymore because it's really, this is all you care about right here. Fx is 6x minus 12. Fy is 4y plus 12. Set them equal to 0. X equals 2. Y equals -3. Now, is there a maximum temperature? Since they're asking, we actually do have to go find Fxy, which is 0. Fxx, which is 6. Fyy, which is 4. D though is nice. It's 6 times 4 minus 0 squared. So it's 24. It's greater than 0. Now it's a min if this is positive. So since Fxx is greater than 0, I believe you look back in your notes, it's a min. So it's a min at 2, 3. So now we got to go and calculate that min. But the answer here is, go grab the actual picture, is it has a min. There is no max. It occurs at 2, -3. Is that right? Is it really negative? And then you plug those back into the original, into this right here. So let's do that. X is 2, y is -3, and your function is 3 times x squared plus 2 times y squared minus 12 times x plus 12 times y, and you get -30. Well, that worked out nice.
There's no maximum. Okay.
Yeah. That does take us to the end of our lesson tonight. I really appreciate you scheduling. I'd be happy to help again. You know, and I'll send you the notes here shortly.
All right. Thank you so much.
You're welcome. Have a great night. Bye now.
Bye.